Hi. So welcome to lesson number 3, module 11 of the Big Data and Hadoop Developer course. So in this lesson, we will be understanding about HBase. So before we proceed with the lesson, let's have a quick recap of the previous lesson. So in the previous lesson, we learned about some of the real world problems such as real-time data processing, ad targeting, connection suggestions, and how a possible solution such as HBase can deal with this. What are the characteristics needed for that? So in this lesson, we will see what is HBase, its history, key features, the architecture component, and where it is used. Well, HBase is a NoSQL database which falls into a category called column-oriented NoSQL databases. It is an open source and distributed database, and it is used when we need near real-time read and write access to big data, when you have billions of and millions of columns sitting on top of Hadoop. And HBase is not a traditional relational database. It does not support SQL scripting. Now the first thing you need to understand is how HBase stores the data, or how does the schema of HBase looks like, where in the case of HBase it divides the data into tables. So the top level hierarchy here is called tables, and the data is stored in the form of key and value pairs. So if you look at an example that I have here, the first thing you need to understand here is that for every data that you're inserting into an HBase table, you must have something called a row key. So here you can see that I have the row key, which is the email addresses basically of different users. The row key uniquely identifies the data that you're inserting into the table. Now within the row key, you have a concept called column family. Column family is a collection of columns which are accessed very frequently. Now a column family can have only one column, maybe more than one column. So here I have two column families. One column family called user data, another column family called pictures. Inside the column family user data, I have two columns, first name and last name. Inside pictures, I have only one column. So you can see that inside the column family, you have the individual columns, and the first name, last name, and pictures are there. So when you just want to access the data, what you do is that you just mention the row key. So in this case, let's say you want to access the data Vijay at apache.org. So when you simply say that I want the data related to Vijay, you get all the data. Or you can simply say I want Vijay's data related to column family user data, then you get only first name and last name. Or you can say I want Vijay's data, column family user data, first name, then you get only first name. So this is the way in which the data is stored. So you have a row key which uniquely identifies the data you store, then column families which are collection of columns, and individual columns are going to have the entry. Now first of all, HBase has a lot of characteristics, and the first characteristic is that it is multi-dimensional. So in a traditional RDBMS, it is two-dimensional. That means you need at least two coordinates to access the data, the row and the column number. When it comes to HBase, it is at least three-dimensional. That means if you want to access data from HBase, you need the row key, you need the column family name and the column name. So that is why we call it as multi-dimensional. It is sorted map. By default, the data you store in HBase is sorted. It is sparse, meaning null values are not stored, and consistent. So let's understand some of the key features of HBase. So it has near real-time speed. So by that I mean that it is almost real-time speed, even though not 100% real-time. The scalability of HBase is really high, since typically HBase is installed in a Hadoop cluster. It has the same scalability as a Hadoop cluster. It is very much flexible in the way you can store structured, semi, and even unstructured data. And the automatic replication and fault tolerance makes it reliable. And there is load balancing and sharding. And it is very easy to use. You can use your Java APIs and Thrift and REST gateway APIs to connect to HBase, and store data very easily. So let's understand the history of HBase. In 2006, Google made open a paper called Bigtable white paper. So Google was using their own NoSQL database called Bigtable, and in 2006 they made the white paper of this Bigtable public. And in 2007 Hadoop's contribution started towards building a NoSQL database which was based on this Bigtable. In 2008, it became a sub-project of Hadoop, and in 2010, a top-level Apache project, and in 2011, we had the first HBase release, which is 0.92. So HBase is quite new to the family, I should say, and we have the latest version now in HBase. Now, let's understand how you are reading and writing into HBase. So typically what happens is that when you install HBase in a cluster, your tables will be divided and stored in multiple data nodes. So we are assuming that you're installing HBase on top of the same Hadoop cluster. So you have the data nodes there. So typically your table will be divided and stored on top of the data nodes, just like your data is getting divided. Now when you want to write data, okay, so the first thing happens is that when you write any data to HBase, it goes to something called memstore. Now memstore is the in-memory or the RAM that is available on the data node. So whenever you want to write something, it will not persist the data to the disk, rather it directly go to this memstore, which is your RAM. At the same time, it will write to a hard disk called write ahead log. In case if the machine crashes or reboots, if you want to recover the data, then you can recover it from this write ahead log. Over a period of time, what happens is that your memstore becomes full and the data is persisted to the HDFS blocks. When you want to read the data, what happens is that you look at the memstore first, because most of the data will be there in memstore. If it is not found in the memstore, you have something called memcache, which is the cache memory of the RAM. And if it is not found in the memcache, also you look at it in the HDFS. So this is why HBase is really faster, because whenever you are writing any data to HBase, it tries to keep the most frequently accessed data and most of the data in the memstore, which is the RAM, so it can provide the result in real time. So here you can have a look at the HBase architecture. So what we have in HBase is somebody called the master server or the HMaster and the region servers. Now HBase has three major components called client, master and region servers. Now the client is just to access HBase and read or write the data. The region servers can be added or removed as per the requirement. Region servers are typically your data nodes. When accessing the data, client connects to the region servers directory. Region assignment, the DDL creation operations are handled by HBase master. So HBase master is responsible for coordinating with the region servers and for all operations such as create, delete and updates. You also have a coordination framework called Zookeeper, which maintains a live cluster state. So this connectivity between your HMaster and region servers and the backup HMaster is maintained by this Zookeeper. So here I have a detailed explanation of the HBase architecture. You can see that there is a client who will connect to the Zookeeper first to get the information about the data that it wants to read or write. Once it has the metadata information, it contacts the region servers, and from the region servers it can read or write the data. So the region servers are typically your data nodes in Hadoop. Now let's understand this concept in a little bit in depth. The region servers are software processor that gets activated to store and retrieve data in HBase. In production, they are deployed on its own dedicated node. In HBase, a table gets created and then data starts getting stored and retrieved from the table. When a table in a region server grows beyond a limit, HBase system splits into another region server. This is called auto sharding. So what happens in HBase is that, let's say you're creating a table. The table will be stored in one of the region server. And if the size of the table becomes bigger and bigger so that a single region server cannot handle it, HBase will automatically split it, that's called sharding, and store it in another region server. So in very large deployments, you will have a table which is stored in tens or hundreds of region servers. So a region is actually part of a table which is served by a particular slave machine. And a region is when the tables are split, a split becomes a region, and they are stored a range of key value pairs. Each region server manages a range of key value pairs. A region consists of memstore and a set of h-file. Now the memstore is the RAM part which stores the data, and h-file is the data which is persisted to the disk. So the HMaster component monitors the region servers and assigns regions to them. So HMaster is responsible for automatic sharding and assigning new regions, etc. Now the component called Zookeeper comes integrated with HBase. You don't have to install it separately. It keeps a track of all the region servers in cluster and informs the HMaster. Basically, Zookeeper is a coordination framework. So let's understand when HBase has to be used. HBase should be used when you have high volume of data, near real-time operations, column-oriented data, unstructured, and when you need high scalability. So to wrap up, in this particular lesson, we have learned the history of HBase, internal architecture, key features, components, and where HBase should be used. That's all for this lesson.